Welcome to this session in the course on computer programming. Today we shall be discussing how to handle character strings in our program. So far we have seen in the earlier sessions that we can have a variable of type char in which we can store an ASCII value of a character. The ASCII code is actually a numerical value which can also be treated as an integer number. We also discussed how strings can be stored as a sequence of characters in an array. In this session we will discuss how strings can be meaningfully handled. In particular, we will see how to perform some useful operations on string. In particular, we will look at couple of inbuilt functions which are provided by C++ library. It is important to understand that C++ actually handles character strings in two different ways. To see why it is so, it is useful to look at some historical context. Bjorn Strostrup, who invented C++, designed this language essentially building on the language C which existed then. The language C does not support objects and object oriented programming. It is classified in fact as a procedural programming language. C++ on the other hand was designed to support object oriented programming style in addition to permitting all the procedural features of C language. You will notice that whatever we have discussed in this course so far essentially pertains to the procedure features of C language used in C++. So, let us continue defining and using character string in C++. We have seen already that string can be stored in a char type array. We note that an extra character \0, which is actually a zero value, absolute zero value, is stored at the end of such a string. Obviously, the size of the array which we define to hold a string must contain an additional element to hold this extra value. If the string does not have a blank space within, we can actually read that string directly in an array using our cin statement. The special character \0 is automatically inserted by the compiler at the end of the string read by cin. On the other hand, if we form a string inside an array, a char type array in our program by ourselves, then it is our responsibility to ensure that a \0 character is inserted at the end. Here is a program to determine length of a given string. Notice that a string is defined as array word of length 6. Note that this string, this array can contain a word of only up to 5 characters, because the 6th character position must be used to insert a \0. Of course, the \0 can occur earlier if the length of the string is less than 5 characters long. So, here we read the input string by simply saying cin word. We now scan the string. We are already familiar with scanning an array. We have an index I which varies from 0 to less than 6, increasing by 1 every time. This is the standard for loop construct for iterating around all elements of an array. All that we do is we examine if the ith character or ith position of the array word contains a \0. If it does, the string has ended, we break the loop, otherwise we come out of the loop here. Whatever be the value of I at that juncture is assigned to word length. We simply output the length of the string as word length. This program should work properly, we so expect, but look at the interesting behavior. If we execute this program using code blocks, for example, and give an input string as hello, the program shows the correct length as 5 because the string hello has 5 characters. However, if the input string is abracadabra, the program shows the length 6. Why does it do that? Actually, some compilers will work differently and even produce a runtime error. You can guess why. If you go to the previous slide, you will notice that the for loop is running for I equal to 0 to I less than 6, naturally because our array size was 6. However, when we input a larger string such as abracadabra, the compiler, depending upon how it is implemented, might work either terminating the loop execution as directed or giving some runtime error because you are trying to stuff additional characters in an array which is less than 11 characters long. So, the cin command merely reads all characters of the string into the consecutive elements of array word and inserts a \0 at the end. Now, this works for input string which is less than 6 characters as we noticed, but abracadabra has 11 characters. Now, C++ will do one of the two things. In the code blocks, if we put this kind of string as input, it will now put additional characters in subsequent locations beyond the size of the array word. Now, that is of course pure nonsense because we have not allocated any memory to hold any extra characters, but this is what C++ may do. The for loop will however exit after completing its normal run, which is end of I equal to 6. So, value of I will be 6, which will get assigned to word length. Word length will be printed as 6, but the array word will not have a well formed string because the \0 is not available on the 6th position. So, C++ expects us to check if array bounds are exceeded. It is our responsibility and not that of C++. A better program is to do this. If I equal to 6, then we say invalid string. That means the cin had read a string, but did not perhaps find a string of less than 6 characters. So, it did some fancy stuff, but when we came out I was equal to 6. Now, if even when reaching I equal to 5 I do not find \0, which was the 6th position in the array, then there is an invalid string. So, we return with an error. Otherwise, we print the length of the string is word length. But a better strategy would be to always declare an array with sufficiently large size. For example, char word 50, typically the words are smaller than this. Therefore, we are very sure that even if we read a string inside, you read a word inside this array, the word will be properly accommodated. In fact, C++ provides a library function to actually automatically calculate the length of a given string. It is called strlen. We need to include the corresponding library in our header. So, we have to say #include C string. The C string library is actually C type of string handling library functions. When we include that, then in our program, after reading the given input string in our char array say word, we can simply say word length is equal to strlen word. This will correctly calculate. In fact, it does exactly the same thing that we did in our program. It will scan the word array till it finds a \0 and will correctly calculate the word length and assign it to the left hand side. Going further, a sentence may have many words separated by blank spaces or by punctuation marks. The cin statement of C++ unfortunately will stop reading input when it encounters a blank space, because a blank space or a return key press indicates end of one input value. So, even if I want to read a string, the string cannot contain blank spaces. We need a facility to read complete lines of text independent of whether it has blanks in between or not. Fortunately, a library function provides such a facility. I have indicated here the use of a function called getSstring, which actually stands for getString. You may want to note that the actual function getS is a deprecated function. However, later on when we discuss file management and file handling, we shall see how the properly defined functions exist to do such things. Currently, however, getS works on almost all the compilers that we have seen. When we use such a function getSstring, it will read an entire line up to the end of the line character that we type in. We must of course include another library called cstdio. This is nothing but our stdio or standard input output stream kind of library, except it is a C style library, so it is called cstdio. This function will read all input characters up to the new line character. However, the new line character itself, when it is encountered, will be replaced internally in the array string by a \0. So, here is a program to count words in a sentence, for example. Imagine that we have written large number of words in a sentence, hello, how are you, for example, each separated by another with one blank. How do we count these words? Well, first of all, we include the cstdio library, then we define a sentence array, which is a char type array, fairly long, it can hold 200 elements, actually 199 characters, because the last character position you will remember must be reserved for a \0. I ask user to input a string and use the getS function. This getS sentence will get whatever sentence we type as input. Please note that if the sentence is shorter than 109 characters, which is what we expect it to be, then automatically a \0 is inserted by the getS statement. So, we get a well formed string inside the sentence. All that we do now is that we set up an array scan for I equal to 0. If the ith character is a \0, we know that the sentence has ended, and therefore we determine the length as equal to I. Please remember, we could also have used the function to calculate the length of a string that we introduced in an earlier example. Next, we proceed to count words. All that we do is we scan the array which holds this sentence, called the sentence array. You will recall that the standard scanning practice is to set up a for loop which varies from I equal to 0 to I less than length in increments of 1. This will examine every character stored in the sentence. If that character is a blank, I know that one word has ended and another word will start next. All that I do is I increment the number of words by 1, just put end of line character and continue. At the end, I will output the sentence I, which is actually the ith character. So, please notice what I am doing. If the sentence is not blank, I will come out here and just output that character. If the sentence is blank, I will increase the number of words by 1 and put an end of line character. This will ensure that continuous characters of a word will continue to be printed on the same line, but whenever a word ends, a new line character is inserted, so that the next word will be printed on the next line. This will continue, and when this entire for loop ends, I would have finished my scanning and I can simply say the given sentence contains so many words. Notice that num words would actually contain the total number of words counted by this mechanism. Does it work? Well, it does print each word on a separate line, but the word count you will find is 1 less than the actual. This is a very interesting phenomena. The logic of our program appears to be all right, but because the last word did not have a space after it, the word count does not get incremented. We should actually check for end of a word by looking either for a blank or for end of string, which will be encountered when the last word is finished. This should work. There are some interesting behaviors that you may still notice for different combinations of input. I leave it to you to find any other correction that may be required for this program. In summary, we studied in this session how to handle simple strings of character. In the next session, we will consider some more problems which require us to handle more complex strings. Thank you.